Now we're going to turn the factorial example that we just demonstrated with this diagram into code. Okay? Now, the first thing we need to do is, of course, write our, so remember that the method needs a second parameter. Okay? So let's first write our Java documentation and just tell what this method does. Of course, it computes the factorial of n using tail recursion. Okay. N, of course, is the number we want to compute the factorial of. The accumulator is going to be the thing that keeps track of the current value of the factorial. Okay. Then we're going to return, of course, n factorial. So, kind of the same thing we did up here. So let's actually just copy this to make it consistent. Okay. Now, what did we say we were going to do in the base case? We return the accumulator itself because there's nothing left to do. Remember, after we do the after we built the result as a parameter, there's nothing left to do because there's nothing outside of a tail recursive call. There's no unwinding that needs to take place. Therefore, we just return the accumulator. So we return the accumulator. Now, if you remember, how does the value of n change between each recursive call, and how does the value of the accumulator change? Well, n decrements by 1, and usually this behavior is going to be the exact same as what you did in the standard recursive version. Okay, and then how does the accumulator change? Well, we said, because we're smart, we said that the accumulator just becomes n times ACC. So notice that we're kind of simulating that by just moving this n times inward into the recursive call. Okay, so we're moving this n times operation into a parameter for the method. Okay, so that's the only way, or the only difference between these. Okay, we have the base case difference, and then we have the accumulator addition. All right, now let's go test this. So I've already written some test cases here. So we need to decide what the starting value of our accumulator is. So this is going to be problem dependent. So for factorial, what do you think we should do? Well, I kind of already spoiled it in the previous video, but let's say that if we chose 0 for the accumulator, then of course we'd just be multiplying a bunch of zeros, or numbers by 0, and then we'd eventually get 0 for every factorial, which is of course not correct. So 1 is the appropriate answer. Okay. And if you notice, this accumulator is the same, or the starting value thereof is the exact same as the value that we return from the factorial method, from the standard recursive version. And this is a general pattern that you'll see when you're converting standard recursive methods to tail recursion. Okay, so if you see something like this, you're probably going to be using that as the starting value for your accumulator. So let's fix that. Let's run this and see what we get. Of course, everything should pass, and it does. Okay. Now, this is all. So I didn't use, or no, I'm sorry, I did. So this is all well and good. We have the tail recursive version of factorial, and it all works as expected.